Hi everyone, my name is Anvita Bansal and the problem that we are going to discuss from the SD sheet today is rearrange array alternatively. So let's move to the problem and understand. So you're given an array, a sorted array of positive integers. Your task is to rearrange the array elements alternatively. That is, first element should be max value, second should be min, third should be second max, fourth should be second min, and so on. So this is what is important to note here is that you should solve this problem using without any extra space. Okay, so I'll explain you what you need to do in this problem. Let's have a look. Let me check if you can see my screen. Okay. So moving to the whiteboard. Okay, fine. So what do you have here in this problem is that you are given an array which is already in sorted order. So let's write an array like this: 1, 2, 3, 4, 5, 6. Let's say this is the given array. Now, what should be the output array? Output array should look something like this, that it starts with the maximum value at the first. What is the maximum of this array currently? It is 6. Then what is the minimum value of this array? It is 1. Then it should be right next to the maximum value, right? Then after writing these values or placing these value at their respective indices, what is the largest value now in the array? That is the second largest value, that is 5. So you place 5 right next to this 1. Now what is the minimum value after 1? Once you are done with the iteration which holds this value 1 in your array, now the minimum value is 2, right? So you put 2 here. Now what is the maximum value in the remaining array? This is 4. And what is the minimum value? This is 3, right? Let me check if I have done this right. So that is what you want: 615243. Okay. Now, how to solve this problem? One very easy approach is to use an extra space. That is the first approach that can come to anyone's mind. That is using some extra space. I have this given array. This is the array that I have been given. Okay, I use some extra space of another auxiliary array, let's say this, and I keep a pointer. This is min pointer and this is the max pointer. I keep the track of these pointers and I run a loop over this array. Okay, so as soon as I find a max value, let's say my I currently is at 0. Okay, I can use two things. I can use a flag boolean of flag value which will tell me at what index I am, or even I can also keep a track of even and odd indices. If you check, this is 0, 1, 2, 3, 4, 5. So whenever you are at even indices, you are looking for the maximum value which is left in your array, right? So currently I have to fill 0th index. What is the maximum value? That is 6. Okay, you do max minus minus. Now your max currently is at this position. Okay, and your min is still at this position. Now you have to fill for index 1. Index 1 is odd. You will check for the, whenever there is an even index, check for the maximum value which is pointing to in your array. Check for max index. Whenever the index is odd in your auxiliary arrays iteration, check for the minimum index value in your given input array. So minimum is pointing to 1. So store 1 in your array. And also increase the count of min, because now the min of the remaining array would be 2 and the max of the remaining array would be 5. What index do you need to fill now? Index 2, which is even. Whenever the index is even, what value do you store? You store the max value. So you store 5 here, and also decrement the count of max after every iteration in which you are using the value. And if you're using the min value, you'll increase the count of min value, min index. Fine. Now you have to iterate for the third index. Third index is odd, right? For odd, you check for min value, which is 2. Now you increase the count of min value and min comes here. Now the next index that you want to search for is 4, which is even. In even indexed value, you need to store the max of the array, which is 4 in this case. Now you have to check for the last index, which is 5, and also max minus minus, so max and min at this stage points to the same index. Now you're checking for an odd indexed value in your array, and for odd you check for the min. Min is pointing to 3, so you store 3 here, and that's how you have created another array. This is an auxiliary space you have taken, space O of n, right? Now the problem says that you need to solve this problem without any extra space. Without any extra space. This makes this problem a good problem actually. Using the space is nothing, and then you copy. Also, the last step would be copy. First step, you create the array. You create extra space, extra array, and then you if you can see my screen, can you write it in the chat? Okay. Fine. So first thing is what you do, you create an extra array, then you iterate over it and also start filling up the array. You start fill this extra array, fill array accordingly, according to these two conditions. And then the third thing is you copy your contents of the auxiliary array, copy the contents of your array you created back to the input array. Then that is how you will change the values in your input array, because you don't need to return here. The function that you are given is of void type. Now without using an extra space, how you're going to do? I'm just checking if you guys are still able to see the stream. Okay, coming back to whiteboard, how to solve this problem without using an extra space? See, then have a look here. You are still given 1 2 3 4 5 6. In order to solve this problem without any extra space, we are going to use some trick here actually, and the trick is completely based on mathematics. Mere mathematics you need to do here, and the tricky part is to think of doing that I'm going to explain now. So since this array is always sorted, which you are given, so you know the maximum element would be present at n minus 1th index. Now just keep faith on what I'm going to do, and then after we're done with discussion, you will understand that why we did what we did basically. So let's take one key value. Let's say I take some key value which is greater than my max value. Okay, it can be anything. But if you take the nearest max value to this key, then your calculations will become easier. So let's take 7 as of now as your key. 7 is your key. Now what I want you to do is, for every even indexed value, that is indices, like if you take an array like this, okay, 0 1 2 3 4 5, then what you need to do, this is 0 index, this is 1 index, this is 2 index, this is 3, this is 4, this is 5. Okay, and for even index I want the maximum value to be stored here, and in the odd indices I want the mins to be stored, right? The mins at that stage and the max at that stage for the array. Now when you are at even position, you're going to check that I have 1. Okay, and the role of key you'll understand. Also there are 3 pointers that I'm going to take in all. So there is this pointer I with which you are going to iterate over your array. Then there is this j pointer that is going to hold the minimum of the array, and the k pointer which is going to hold the maximum of the array. Whenever you are at even position, what you're going to evaluate is that you check for the max value. Okay, let's say given is at this position, the max will be stored by what? Max will be stored by k. ARR of k remainder, this key value. Okay, what will be the remainder? Whenever, see, we know that all the elements that are present in this array will always be less than your key. Whenever the given number is smaller than the number that you want to divide it with, okay, remainder would be what? Remainder is always going to be equal to the n number itself. For example, I want to divide 1 with 7. Okay, what will I get? See, it will be something like this: 7, I'll get something like this, right? That is 7 into 0 plus 1, that is equal to 1, right? So remainder is what? The number itself, and this is the divisor, dividend, divisor, and quotient, right? So what I'm going to do is multiply this value with key again and add what is present in your ARR of I at that position. I'm writing the formula for now. Just hold for some time. I'll tell you why we have written so. Now, in case of odd, in odds, we are storing the values which actually J will be pointing to, because J is pointing to the minimums, K is going to hold the maximums. Okay. So I want ARR of J. ARR of J, remainder, key, multiplied with key plus your ARR of I. Now see what we are doing here. Have a look. So when my I is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is, just to check if you can still see my stream. Hope you can. Right, you can. Okay. So initially my J is at this position. Let me take some other color pen. This is where my J is at. This is where my K is at. And this is where my I is at. Right? And what are these indices? These indices are nothing but 0, 1, 2, 3, 4, 5. Right? In the first iteration, what is happening? You are at I0. So you want to store the value in this array. You are at 0th index. Let me write it like this. 0, 1, 2, 3, 4, and 5. So when you are at 0th position, 0 is what? Even. 0 is even. So your this ARR, basically ARR of I currently, which contains 1, right? It contains 1. So ARR of K, what is at K? That is at K you have 6. 6 remainder, what is your key? We have taken key to be 7, right? Just greater than the last value. Remainder 7, what will it be? 6 remainder 7 would be 6 only. Multiply with the key, that is 7 6 are 42. Then add with the value present in your array at that point in time. What is this value? This is 1. So this is 43. Let's store 43. I'll tell you why we are doing. Just keep understanding the flow of the calculations that we are making right now. Then now I am at index 1, which is odd. For odd index, also, once we are done with this iteration, my I will be incremented. Simultaneously, I evaluated the even index value, and even index makes use of the index K. So also I'll decrement K now, because my max for the remaining calculation now would be 5, right? J will be at its own position because J has not been touched yet. No evaluations have been made using J. Now my I is at this index. I is at which index? 1 actually. This is 1. 1 is odd index, right? So if I use ARR of J, what is J is holding the mins of the min at that point in time of your array. And for odd index, why are we evaluating ARR of J? Because we know that we have to, in the array, we have to store the elements in such a way. Once we are storing max, that is held by zeroth index, and then we have to hold the minimum of the array in the first index. Then second index should hold the maximum of the remaining elements in the array which have not been evaluated, and then followed by the minimum at that point in time. So this is the pattern that we have observed, that all the even indexed values will have the maxes and the odd indexed values will have the mins. That is why we have made the calculation like this. Okay, for index 1, what are you going to do? What is present at ARR of J? 1. Okay, 1, remainder 6. It would be what? 1 only. Multiply it with key. Multiplying it with key is 6. That is 6. Add with your ARR of I. ARR of I is 2. 6 plus 2, 8. So just store 8 here. Okay, these are the calculations for 0 and 1. Let's check for index 2. For index 2, you'll check. Now, since we are done with this calculation, we'll increment the count of J, increment the count of I. Now you are checking for index 0, 1, 2, 3, 4, 5. Now you are at this index 2. What is happening at index 2? You check whether it's even or odd. Okay, it is even. So for even, I'm going to use this formula again this formula, ARR of K, because K is holding the maximum. ARR of K is what? K is at this position, so it is 5 right now. So 5 remainder, your key is 7, so 5 remainder 7 multiplied with 7 only, and plus ARR of I is holding this value 3. So what will it become? 5 remainder 7 means 5 multiplied with 7, 35, plus 3, 38. That is what you are going to store here. Also, now your I will be incremented, and since you were evaluating the maximum, K will be decremented by 1, I will be incremented by 1. Now you are at index 3. For index 3, you check this is odd. So for odd, you use this formula. And what should be stored for index 3? For index 3, I'll check ARR of J. ARR of J is 2, right? ARR of J is 2. So 2 remainder, your key is 7, okay? Multiplied with key only and adding the value present at ith index. So what is that ith index? That is 4, right? So 2 remainder 7 is 2, multiplied with 7 itself is 14, plus 4 is 18. So that is what you are going to store here, 18. Now what? I will be incremented to 4. Now I is at this position. And since we were evaluating for odd, we were dealing with the minimum index value. So J will be incremented to this position. Now J is at 2, K is at 3, I is at 4. Evaluating for 4. We'll check for evens formula. What is that ARR of K? ARR of K is 4. ARR of K is 4. 4 multiplied with your key. 7 4s are 28. 28, sorry. ARR of K remainder key. Let me write it. 1 second. Fine. Now, if I were to check for index 4, your I is 4 right now. Your J is at index 2 right now. Your K is at index 3 right now. So ARR of K, since I is even, ARR of K is what? 4. 4 remainder 7 multiplied with 7 plus ARR of 4. What is ARR of 4 right now? It is 5. Okay. So 4 remainder 7 would be 4 only. 4 multiplied with 7, 28 plus 5, 33. Fine. Now what? 1 second. Now we are at index 5, and since we are done with this calculation, we used what? ARR of k is what we used, right? So k will be decremented to this index now. Okay, now I is 5, j is still 2, k is now also 2. What are we evaluating for? What is your ARR of j for index 5? ARR of j is 3. So 3 remainder 7 multiplied with 7 plus ARR of I. ARR of I is at index 5. Index 5 holds 6 in the original value. So that is remainder 3 multiplied with 7. 3 remainder 7 would be 3 only. So 7 is a 21. 21 plus 6, 27. Now how this is what your array would look like now after these iterations and using these formulas. But is this what we want to return? No, our answer array should look something like this. If I show you back our answer array should have looked like this: 615243, right? So 615243 is not what we see right now. Let me write the answer array also. So why we use this evaluation and this new type of formula that we created using some mathematics? Why we did so? Anyway, right now we are getting an array which looks something like this. So what was the purpose of using key and doing all those manipulations using key? See, the reason is, first thing, we were not allowed to use extra space. Second thing, we wanted to make calculations such that by the end of all the iterations, we can find an array like this. So can you see can you use a little trick here, and using key and this array, using key and this array, can you form this array? Let's check. So if you divide 43 by your key, 43 is your value at 0th index and key was 7. If you divide 43 by 7, what are you going to get? You are going to get 6, which is this value. If you divide 8 with 7, 8 is present at index 1, 7 is your key value. What are you going to get? 1. If you divide 38 by 7, 38 divided by 7, 5. 18 divided by 3, just focus that here we are doing divisions, not remainders, right? 18 divided by 7, sorry, 18 divided by 7 is what? 2. Then we have 33 divided by 7 is what? Sorry, 4, right? 7, 4. Then we have 27. 27 divided by 7 would be what? 3. So do you see this pattern? That after making all the calculations using this key and these formulas in the input array, we get an array like this. Just use one more loop from 0th index to last index and divide all the values with the key that you chose and store that in your given index of the array which you are iterating. And the result that you will get will be your output array. Is it clear? I hope you have understood this problem and the solution, why we use those manipulations. Let's move to the code and understand. Before that, I'll just show you this once again, what we used. So in order to get the final, see, 3 steps. Let me write this again. We did 3 steps basically. The 3 steps were: first step, choose another variable, not another variable, let's say choose a value, choose a value greater than the maximum value, and the nearest that value is to the max value, easier the calculations are. Then second thing, on the basis of two cases, even index and odd index, right? So based on these two things, you are going to make some calculations, and the calculations are something like this. Okay, before these cases also, third thing is that you are going to keep track of three indices which will store your minimum, track your minimum, your maximum, and the current value that you are going to store. So min, let's say, will in our case is represented by j, k at k by max with k, and the current is the iteration that we are making using I. So whenever you find an even index, you have observed that in even index cases, you are storing the maximum value, right? 0, 1, 2, 3, 4, and 5. So what we observed was that initially the array was in sorted order, right? Whatever it was, like 1, 2, 3, 4. What you wanted was that maximum followed by the minimum at that position, not position at that instant. After this, what will be the max and min left? Max would be 3 and min will be 2 for that case. So then followed by max again and its minimum. So that is how we want to store, right? So you observe that the maximums are being stored by even values. This is just some observe based on the observations we came up with this formula which I wrote, that ARR of I, if even, then ARR of I is ARR of k, because k we are using to store the maximum, remainder that key value that you are storing multiplied with the key again, okay, plus ARR of I, the value that is present. All these calculations are made just because of these manipulations, that by the end of the iteration we can somehow find the array that we want to return. Okay, so in case of odd, ARR of I should be something like this: ARR of J, which is storing the minimums, remainder key, and you always know this for a fact. ARR of J remainder key, whatever you divide with key, basically you are always going to get ARR of J as the remainder, because it is going to be smaller than the key. Your key is, because you have chosen key which is greater than the max of the array, so all the elements would be smaller than your key only. So whenever you divide something which is smaller than the value that you are dividing with, for example, you want to divide 5 by 8. So 5 is smaller than 8, right? So whatever you choose, you are always going to get 5 as a remainder. So basically, whatever we are using, we are going to get these values at the remainder, and basically we are multiplying it with the key and adding to the current element, right? And then later on, to get the final value, we are dividing that back with the key. So what are we going to get? The original value that was supposed to be filled, which was present in the input array, right? So multiplied with key plus ARR of I, and simultaneously you will reduce the count of k index and increase the count of j index, because you are always changing your max and min at every iteration. So let's code this one now. Look here. So let's take int I, int j equal to 0, int k equal to n minus 1, and then we have taken a long type of value here, key, which is your ARR of n minus 1 plus 1. Okay, now let's start the iteration from 0th index till last index, and how to store. If your index is even, I remainder 2 is 0, right? What are you going to do? ARR of I would be ARR of maximum is being stored by k, remainder key multiplied with key, and add ARR of I itself, and then k minus minus. Otherwise, in else condition, what do you want to do? Your ARR of I would be ARR of j, because that is storing the smallest elements at that during that iteration. Remainder key into key plus ARR of I and j plus plus 2. What is what you want to do? Now, once you are done with this entire iteration, you will be left with an array which I just showed you, which was still not the output array. So if you iterate over that array, which will be formed after all these iterations, and you iterate over your array again, and just simply divide that array with key ARR of I divided by k. Then the array that should be stored in ARR of I. And then the value that you should get should be what is required. Let's check. So you can see that this is the end of this problem. The entire just, if I were to tell you, is that we use certain mathematics based on the division and remainder thing that we use here, that we have used here. It's just based on that. And since we did not want to use an extra space, we came up with this solution. I think that is all about this problem for today. If you have any doubts, you can write it in the chat, else we can wind this up. Fine then, everyone. That's all for today. See you in the next lecture. Thank you. Also, before leaving, the time complexity for this code would be O of n, because the maximum how many operations are we performing? We are performing at max one iteration, that is, we are operating over each element of the array, that's taking maximum O of n time. And also in the end we are again iterating, but that is not nested within this, right? This is the second operation we are performing, which is again of O of n time complexity. So total, if we take, it's O of 2n, and we can ignore the constant here, so it's equal to O of number of elements in the array. So linear time complexity. That's all then, everyone. Thank you. Bye.